Okay, we're going to start reviewing numbers 91, not to the end probably, but we'll see how far we can get. So number 91 states, how many electrons does barium have to give up to achieve a noble gas configuration? If you go back to the periodic table deal, I've been looking like that. Barium's here in group 2. Group 2 we know has 2 valence electrons. You could either add 6 or you could remove the 2. We go with the lower number, remove the 2. It takes on the configuration of a noble gas now. And the noble gas prior to barium is going to be xenon. So for that one, number 90, it's going to say, all right, what are they going to? They're going to lose 2 electrons. The answer is B. Number 92. 92, which of the following does not form an ion with a charge of +1? +1, once again, if you remember your periodic table, +1 is the alkali metals. It's the first group. They're going to lose 1 electron to have a noble gas configuration. So they have to be in group 1. And the only one you're going to find in group 1 is going to be, actually all 3 of them will be, 3 of these will be in group of +1 alkali metals. The other one, though, fluorine over here, is a -1. So the one that is not is going to be fluorine, and that's going to get you A. 93. 93 is going to ask how many electrons does nitrogen gain in order to achieve a noble gas. Nitrogen is right here. It's in group 5. It needs 3 more to get its octet. Therefore, 3 more electrons. It's going to be a -3 charge. The answer is going to be C. Number 94. What is the electron configuration of O with a 2-? O by itself we should know is 1s2, 2s2, 2p4. With a 2- means we've added 2 more electrons into the mix, and now we end up without a 2p4 but a 2p6. Number 94, the answer is going to be B. Number 95. 95 says, what's the formula for sodium nitride? First thing you should note, there are no prefixes in the name. Therefore, it is an ionic compound where you have a positive cation, a negative anion. And when you look at that, it's got an I that comes right off the periodic table. Those with ides, it used to be nitrogen. So it's sodium and nitrogen. When I look at sodium and nitrogen, we're going to get sodium with its +1 charge, nitrogen with a -3. When you cross them over, we're going to get Na having a 3 and N with a 1, and you don't need to show it. That'll be your formula. So number 95, the answer is C. 96, what's the formula for aluminum oxide? For 96, we have aluminum. It's in group 3. All of group 3 is +3. Oxide comes from oxygen. It's a -2. Same deal as before. We're going to cross these over so that we get a compound that is neutral. It's aluminum found twice, oxygen found 3 times. If you want to check, you don't have to, but if you needed to check, aluminum, there are 2. Each one is +3. Oxygen, there's 3. Each one is -2. Collectively, that's a 0, and that's what you're looking for with ionic compounds. So the formula was D as a choice. Number 97. 97 states, what is the ionic compound formed when lithium and bromine combine? Lithium +1, bromine -1. Cross them, you get LiBr, which is lithium bromide. The answer is B. 98. Which of the following compounds has the formula KNO3? Well, now we're looking at a polyatomic. You should have your polyatomic sheet with you. I'll give it to you for the final. K is for potassium. NO3 has a -1 charge, and when you look it up, it's going to be nitrate. Just say what it is. Potassium nitrate is the correct answer. That's A. 99. 99. An ionic compound is a bond between, well, I said it earlier, it's when you have a positive combined with a negative. One is losing electrons, and the other is picking them up. Therefore, that is a cation, which is positive, and an anion, which is negative. So we have a compound with a plus and a minus charge within it, but the overall will give you 0. Therefore, 99, the answer is A. Cation and an anion. Number 100. Which of these elements does not exist as diatomic? Now, first off, you have to know what in the world does diatomic mean. It means it has any atom was found twice. It was looking at different gases, and what we're going to have here is periodic table. And I mentioned to you before, it's H, so therefore it's going to be H is diatomic, then start at 7, make a 7. You're going to have then, starting with atomic number 7, nitrogen, oxygen, fluorine. Then you make your 7 going down from fluorine. It's going to be chlorine, bromide, and iodide. These are your diatomics. Hydrogen plus those. So hydrogen plus start at 7, make a 7. What you're going to get out of that, the answer is A. And he is not diatomic. It's a noble gas. 101. Oops, nice if I did that right. 101. For 101, why do atoms share electrons in covalent bonds? Correct answer, to attain a noble gas configuration. So they can't do it on their own. They're not willing to give up any because you're looking at usually a negative and a negative. So I might take something like nitrogen and chlorine. Nitrogen has 5 in the outer shell. Chlorine has 7. Neither wants to give up, they just want to take in, so they're going to decide to share. I'll share 1, share with another chlorine, share with another chlorine, and we'll get to that later. But you're going to end up with NCl3, but they're shared because neither wants to give them up, so they're going to share them. One will have it temporarily, the other can have it also. So at points, they do fill up their octet. So therefore, B would be your choice. 102, which noble gas has the same electron configuration as oxygen and water? Oh, well, oxygen and water, well, water looks like this, and oxygen has its 6 valence electrons in the outer shell, and you're going to share 2 more, so it's taking in 2 more, so therefore now we're going to get to 8 valence electrons. Oxygen now has an octet looking like neon, because it's gained 2 more to get to neon. Therefore, the answer is going to be B. It has an electron configuration such as that of neon. 103. Molecule with a single covalent bond is? Well, let's see. CO2 cannot have a single covalent bond because you have at least that, and that's what it ends up being when you do the whole like electron need and have. You're going to go to CO. Well, how does that? CO, they have 4 electrons. Oxygen has 6. Well, you can't just have a single bond to make it all work because that would only give it 7 and 5. That's not enough. So it needs multiple bonds, so that can't be your answer. Cl, it has 7. And the other one has 7. And therefore, what are you going to do? They can share 1. That's your single covalent bond. The answer is B, Cl2. 104, what type of ion ends in IDE? IDE, we talked about it, will usually be an ionic compound that is, whatever, on this region here, chloride, oxide, sulfide. It is a single element on the periodic table and it would have a negative charge, so it's the anion. 104, the answer is B. And lastly, 105, for this section, I'll stop at this one. When group 2A elements form ions, group 2A is right here. You could add 6 or lose 2, they're going to lose 2. So lose 2, and now they look like a noble gas. The answer is going to be C.